Okay, the plan for today is to work through sections 5.4 and 5.5, solving equations with decimals and averages and probability. So just kind of scratching the surface of some ideas related to statistics. Maybe we'll see some interesting applications and examples where we can use decimals and some real life applications. The idea of the day today, this this kind of popped into my mind over the weekend. I came across a YouTube short. I usually try not to watch those because I feel like they just like I don't know, mess with my focus if I watch too many. Oh, can you all hear me? Somebody in the comments said they can't hear anything. Can anybody else hear me?
Yeah, we care.
Okay, let me just type in the comments. I've done that before where I have the volume turned off, like if I was, in a meeting or something and didn't want to, didn't want the like email blips coming up and then sometimes, I think these days, Zoom. Okay, cool. Perfect. Um, yeah, anyway, so I was watching I saw this YouTube short about Arnold Schwarzenegger's workout program. So obviously, huge bodybuilder guy from back in the day, and he published, I guess, like a book and stuff, and said, what his workout program was, and like on like one day he would do like 35 sets of like shoulder exercises, um, and a lot of people in the comments were like, yeah, I bought Arnold's book and, they wanted to be stronger or have a better physique. And so they were like, hey, Arnold's strong. He's got a great physique. I'll like do what he does, right? And that will be good for me. And they said, they either kept getting injured, they got injured time and time again, or it was just so fatiguing they couldn't do anything else, whatever day they like worked out, or they couldn't recover for the next workout, all these kind of things. And um, so I think this is an issue of survivor bias. And it's something actually that we talk about in probability and statistics, Math 165. Uh, so I think it's important when we're looking back in order to determine how we should move forward. If I'm looking for an example, I need to realize that most of the examples that I'm going to see are quote survivors. They're the people who, did something extreme and it worked out really well for them because we tend to like to read books about, people who did something very much out of the norm and got an extreme result rather than somebody who, said, oh yeah, I went to the gym 3 times a week for an hour and, you know, lost 5 pounds and gained a little bit of muscle. Like, I don't want to really read that person's life story. At least not if that's all that there is to their life story. So, but there were probably 1,000 people who could have been Arnold and who tried to do his workout program or work at that intensity, and 999 of them got injured or couldn't, keep up with it or whatever. And Arnold was the one outlier. Maybe he, got lucky, just didn't happen to like mess up his back or his shoulders or something like that. And maybe other people got unlucky, or maybe he's got better genetic potential, or let's say some, pharmaceutical assistance, or there might be a lot of contributing factors, right? But if I want to decide how to run my life going forward and looking backward at somebody like Arnold, maybe I don't want to just take his strategy and just, plop it right into my life. Or same thing with the author of Rich Dad Poor Dad. Great book. It's a great kind of, basic finance book. It's a very much like a narrative style. So it's not a bunch of numbers and math and stuff. It's just kind of talking about kind of budgeting and finance concepts, kind of, I guess. Um, but the author Robert Kiyosaki, I forget if it was in Rich Dad Poor Dad or if it was in one of his other books, but he basically said that his financial strategy when he was younger was to buy a bunch of properties, a bunch of real estate, intentionally get himself into like crushing debt, and then use that to like spur him on to try to figure out a way to get himself out of debt. And his point was like, okay, well, you're not going to sit around playing video games if you've got, debt collectors calling you off the hook. You're going to be really stressed, and that's going to make you, get off the couch and go out and work hard and set yourself up for your future. And it worked for Robert Kiyosaki. He's, got a bunch of money now and he's financially successful. But I have a feeling, I mean, I don't know numbers on this, but I have a feeling that there were probably, for every one Robert Kiyosaki, there were probably 1,000 people who tried something similar and just ended up going bankrupt or ended up having a nervous breakdown or something, right? So Robert Kiyosaki is the success story. He's kind of the survivor bias of this extreme lifestyle, but you know, uh, you probably don't want to adopt his model, at least not for most of us, right? If you're going to take a risk, take it when you're young. You can recover, a lot better by the time you get to retirement. Financial risk, that is, I'm talking about. But um, maybe a slightly more balanced strategy is going to be much more beneficial for most people. Kind of on the other end of the spectrum, you have Dave Ramsey, who's like no debt, never go into debt for anything, roughly speaking. Um, and I think another, perspective is if you find somebody like this on one extreme, you can use them for inspiration. It's like, wow, that's so cool that, he could achieve this in his life and do this really cool thing with investments and all that. Um, but then seek out kind of the other end of the spectrum as well. Dave Ramsey is an example of somebody who did basically the Robert Kiyosaki strategy, crashed and burned, and he said, wait, I don't think this is fundamentally uh, a good approach. So let me try to find a better fundamental approach. And, he probably came a little too far to the other end of the spectrum with conservative financial decision making. But seeking out both ends of the spectrum, probably a good idea. Um, So don't underestimate the impact of survivor bias, especially when looking backwards at people who were successful. Be careful with trying to emulate exactly what they did, because it's possible that what they did is just fundamentally sound and they got a really good result out of it. But a lot of times it's that they really took a big roll of the dice and got really lucky, right? Um, if you want to be like the top 1% of 1%, if you want to be a large outlier, who are the people who have books written about them and that everybody knows about, um, they have to be almost certainly the result of a confluence of many tendencies, as Charlie Munger has kind of put it in a couple of different speeches of his, that they probably have some really good uncontrollable systematic effects, like maybe Arnold's genetics, um, a good amount of chance or luck, just, Arnold not being, not getting injured a whole lot, or Robert Kiyosaki. I mean, if he had tried that same financial strategy at the end of 2019, he's like, hey, I'm going to do this. I'm going to get all these, these investment properties. And then the pandemic hits. That's not so great, right? Just kind of bad luck. Nobody could have really anticipated that. And also the controllable systematic effects, the things that are the decision making, but there are other things at play, and maybe making, decisions in such a way that it minimizes the effect of the things you can't control and where your outcomes are more closely dependent on your inputs. That might be a better approach. Or you might want to roll the dice, if you're in your 20s and you feel like taking a chance and starting a business, that's how you can make it big, but that's also um, how you can end up in a bit of financial trouble. But a bit of financial trouble is not the end of the world, though. Okay, so moving on to decimals. So 5-4, solving equations with decimals. And we're basically going to go through the same thing we did when we did solving equations with fractions. We're just going to apply our same old equation solving techniques. We should be familiar with them by now, so I didn't explicitly write them out here, but we'll, I think, remember them as we go along. We'll apply our equation solving techniques. We'll solve our equation. We'll isolate the variable. And really what's going to be different here is that when we simplify the answer, instead of simplifying an answer with integers or with fractions, we're going to be simplifying an answer with decimals. So these decimal numbers move around the same way as any of the other numbers. The same equation solving steps work. We're just applying them to decimal numbers. So let's start with the first one. We want to solve m plus 4.6 equals 6.5. Well, we have variable plus number equals number, that pattern. What do? We want to isolate the variable, so we do that by subtracting the number, in this case, 4.6, from both sides. We can add or subtract the number from both sides of an equation. On the left side, m plus 4.6 minus 4.6 just gives me m. And on the right-hand side, I have 6.5 minus 4.6. And again, at this point, I've basically got the algebra out of the way. I've got the variable isolated by itself, m equals something. And now my goal is just to simplify this right-hand side. 6.5 minus 4.6. Well, I want to do 5 minus 6. I line my decimal points up above one another. I want to do 5 minus 6, but I don't have enough, so I borrow one off the 6. 15 minus 6 is 9. Just bring my decimal point down. That's not a 6.15. I just shimmied a 1 in there. That's a 15 in the 10ths place, just to be clear. And then 5 minus 4 gives me 1. And my claim is that m equals 1.9. If I want to check my answer, always a good idea to check our answers. I probably won't check most of our answers just for time considerations, but as you're going back through, if you're rewriting notes or reviewing this material, it's a good idea to go back through and check each of these answers. So is this the right answer? Well, let's see. Is it true that 1.9 plus 4.6 equals 6.5? Well, let's check. We can do 1.9 plus 4.6 and check that equals 6.5. 9 plus 6 is 15. Write the 5, carry the 1. Bring the decimal point down. 4 plus 1 plus 1 is 6. So we've checked that it is correct. Okay, so what if we want to solve k minus 3.19 equals negative 4.6? Well, I have variable minus number equals number. I just add 3.19 to both sides. On the left side, k minus 3.19 plus 3.19, those go away and leave me with just k. And on the right side, I have negative 4.6 plus 3.19. I'll choose to write that as 3.19 minus 4.6. So again, I have my algebra done. I have kind of the difficult conceptual part done. And now I just have to simplify the right-hand side. I just have to do this decimal subtraction. And I've got my colors all backwards now, but so 3.19 minus 4.6. I see the thing I'm subtracting off of is smaller than this thing I'm subtracting, so my answer is going to be negative. And the magnitude of my answer is going to be 4.6 minus 3.19. I need a little bit of a buffer here, buffer 0, so I'll write that 4.6 is 4.60, so that all of my columns kind of match up nicely. I want to do 0 minus 9, but obviously I can't take 9 away from 0, so I borrow 1 from the 6. 10 minus 9 is 1. 5 minus 1 is 4. Bring my decimal point down. 4 minus 3 is 1. So my answer is negative, and its magnitude is 1.41. So k equals negative 1.41 should be the answer. And what I would do now typically is I would check. I would plug in negative 1.41 for K and verify that negative 1.41 minus 3.19, do that operation and verify that equals negative 4.6. Any questions so far? All right, next example, we have number times x equals number. Negative 2.9 times x equals 5.8. Well, we have a property that says we can divide a number from both sides. So if I divide both sides by 2.9, that kind of undoes the multiplication of negative 2.9 on the left-hand side. So negative 2.9x over negative 2.9 just gives me x. And on the right-hand side, I left my negative off of this second one over here. Both sides need divided by negative 2.9. My right-hand side, I have 5.8 divided by negative 2.9. So again, really the same overall strategy that we've seen many times in the past. And what's really different in this section is that now I have the ratio of two decimals that I need to deal with for my simplification. So I need to figure out what is 5.8 divided by negative 2.9. Well, I see that I have a quotient, I have a division, where I have opposite signs. I have positive 5.8 divided by negative 2.9. My answer is going to be negative. And its value is going to be 5.8 divided by 2.9. Okay, so two ways that I can think about starting this problem. I can either think about moving the decimal point, or I can think about multiplying by powers of 10. I know that if I move the decimal point, say 1 to the right on the bottom, then I need to move it 1 to the right on the top, or vice versa. My goal is to make the divisor, the number on the bottom, the thing that's being divided by, the 2.9, I want to make that into a whole number. So I want to bump that decimal point one place to the right in the 2.9, making it a 29. But I have to do the same thing in the numerator as well. That becomes a 58. So 58 divided by 29. I could alternatively think about multiplying top and bottom by the number 10, and that would accomplish the same goal. I might actually realize here that 58 has a factor of 2 in it. It's, in fact, 2 times 29. And the number 29, of course, is just 1 times 29. So my answer has to be negative, and its magnitude is 2. So x equals negative 2 is my answer. And I would plug in negative 2 in for x and verify that negative 2.9 times negative 2 does give me positive 5.8. So if I wanted to check, that's what I would do. And we have a pretty similar problem strategically speaking here. 0.18n equals 5.4. I'm going to divide both sides by 0.18. On the left-hand side, 0.18 times n divided by 0.18 just gives me n. And on the right-hand side, 5.4 divided by 0.18. So just like before, we have the algebraic part done. We now need to simplify the right-hand side of these two decimals. To make my denominator a whole number, I need to bump my decimal point 2 places to the right to give me an 18 on the bottom. But that means that I need to go 1, 5.4 is the same as 5.40. So I need a buffer 0. I need to go 2 decimal places to the right in my numerator as well. So 540 divided by 18. And I could do this a couple different ways. I could do long division, 540, long divided by 18, and go that route. I could simplify my fraction a little bit first. I could do some combination of the two. I guess since we did the simplify fraction approach up here, let's do the long division approach down here. 540 over 18. Does 18 go into 5? No, it doesn't. Does 18 go into 54? Yes, it does. It goes in at least one time. 18 times 2 is 36. So it goes in at least 2 times. 18 times 3, well, that's actually exactly 54. So it goes in 3 times. 3 times 18 is 54. With 0 left over, we bring down a 0. How many times does 18 go into 0? 0 times. 0 times 18 is 0. So a little bit of a funny ending there, but we do want to be careful to actually take this to its conclusion and bring down uh, all of our extra digits, because we wouldn't want to end up with just thinking that 540 over 18 is 3. We really need that extra 0 to remind us that the 3 actually goes in the tens place, not in the digits place. So 540 over 18 is 30. Or over here, n equals 30. Right. And we can always reframe these questions too, right? If I have like amounts of 18 cents, if I have piles of whatever, a dime, a nickel, and 3 pennies, if I have a bunch of piles of those, how many of those would it take to add up to $5.40, $5.4? It would take quite a few of them, right? Certainly not just 3 of them, but 30 of them. I mean, that kind of sounds like it's, in the ballpark of the right answer. Like you shouldn't have to have a room full of dimes, nickels, and pennies to make $5.40. You shouldn't have to have like 3,000 lots of them or something, but you also shouldn't have to just only have 3. So we can check that our answer is kind of, pretty reasonable if we want to, by sometimes reframing the question that's very abstract here in terms of maybe an application with money or with candy bars or something like that. Okay, what about something like this? Y divided by 0.8 equals 0.7. Well, again, I have y divided by some number. I can multiply both sides of the equation by a number. I think I want to multiply both sides by 0.8. So y divided by 0.8 times 0.8, the 0.8s go away, and I end up with just y on the left-hand side. And on the right-hand side, I have 0.7 times 0.8. So I need to multiply 2 decimals. So we line our 2 numbers up, just pushing everything over to the right. It happens to be the case that the decimals line up here, but for multiplication, it doesn't matter if the decimals line up. We multiply for the time being as though there are no decimals. So 7 times 8 is, right, a 6, carry the 5, but it's just really 56 because everything else is zeros. I note that I have 1 decimal place in the first factor and 1 decimal place in the second factor. I need to have 2 decimal places in my answer. So my decimal point starts here, 56.0, for instance. And then I move 2 decimal places to the left to make 0.56. Any questions so far? Okay. We could also have equations that mix fractions and decimals. That's a possibility. How would we handle something like this? Well, we have to kind of decide whether we want to write our answer in terms of a fraction or in terms of a decimal. If I look at this fraction 2/3, I kind of remember that my thirds, they end up like repeating. They're kind of a mess to deal with. I think I'm going to want to write my answer in terms of fractions here, maybe. But just because I have fractions mixed with decimals doesn't mean that the strategy is any different. I have m plus number equals number. Well, I isolate the variable. I isolate m by subtracting 2/3 from both sides. So I get m equals 1.8 minus 2/3. I could convert the 2/3 into a decimal and get like 0.6 repeating, but 1.8 minus that seems like it's going to be a pain to do. But I could also convert 1.8 into a fraction. I see 1.8 is 18/10. I could think of it as 1 and 8/10 as a mixed number, and then convert that mixed number into an improper fraction if I wanted to. And then minus 2/3. I have the difference of two fractions with unlike denominators. What's the common denominator here? It's going to be 30. So I have 18 over 10. To make this denominator 30, I multiply by 3. By the equivalent fractions property, I better multiply the numerator by 3 as well. Minus 2/3. To make this denominator into 30, I need to multiply by 10 on the bottom. Better do it on the top as well. Get a little more room here. 18 times 3 is 54. I could come off to the side and do 18 times 3 over here if I wanted to. No problem with that. So that's 54/30 minus 20/30, or 54 minus 20 divided by 30. That's 34/30. Well, 34 divided by 30, I see that there's a factor of 2 in the numerator and denominator. So 34 is 17 times 2, 30 is 15 times 2. I can divide out the 2's using my equivalent fractions property kind of the other direction. And I'm left with 17/15. So I could either say m equals 17/15, so I could leave it in an improper fraction if I wanted, or I could convert it to a mixed number. M equals, so 17 is 15 times 1 plus 2. So that's going to be 1 and 2/15. Either way that I want to write my answer would be fine. Unless, of course, if you're asked to write it a certain way, or if there's a particular reason, you might want to write it one way or the other. Or here I have a similar example. We want to solve x minus 0.94 equals 3/4. X minus number equals number. Again, I just add 0.94 to both sides. It doesn't matter that this is a decimal or that there are fractions. The algebraic strategy doesn't change. Isolating the variable x, that strategy doesn't change. We just get 3/4 plus 0.94. I guess I could convert this to a fraction. I can make 0.94 into 94/100ths, 94 divided by 100, and do the fraction thing. But 3/4 is actually a pretty easy fraction to convert into a decimal. So maybe I'll go that route for this example. So 3/4 are kind of like, a good old Washington quarter worth 25 cents. 3 of those are 75 cents, $0.75 plus 0.94. Let's add these decimals together. And I could either add them like this, or something that I could realize is kind of if I have one pile of 75 cents and one pile of 94 cents, I could take six off the pile of 75 cents. That would make 69 cents, put them on the pile with 94 cents, and I could kind of make a whole dollar that way, and that's easier to accumulate. So I could either think this way, kind of steal 6 cents from the one pile, put it on the other pile, and then I have 1.69 I can see pretty clearly, or I can just add my usual way. 5 plus 4 is 9. 9 plus 7 is 16. Write the 6, carry the 1, bring the 1 down, bring my decimal down. Either way, I get 1.69. So if I have an amount of money and I pay just under $1, I have 75 cents left. Does it make sense that I started with something like $1.70 or so? Yeah, that seems about right. If I got an answer that was like 16.9, if I start with almost $17 and I pay somebody less than $1, do I only have 75 cents left? Well, no. Or if I got an answer that was like x equals 0.169, if I started with like 17 cents and paid somebody almost $1, well, I certainly wouldn't have 75 cents left over, right? So I can always take these abstract problems, maybe not always, sometimes it's easier than other times, but I often can take these abstract problems and kind of frame them in some real world application and then get kind of a reasonability check. You know, does it seem reasonable? Does this answer that I got seem like a possible ballpark uh, number that I would get in this application? You know, yes or no. Any questions on anything so far? So just kind of like equation solving with fractions. Um, this was a pretty quick section because there's no real new math here, right? All of the stuff that we've done here, it's all stuff we've done before, either equation solving strategies, equation solving steps, or operations with decimals or fractions, something like that. We're just combining them together in a slightly different way than before. So if we're good with our operations on decimals, add, subtract, multiply, divide decimals, if we're good with converting back and forth between decimals and fractions, and if we're good with our underlying equation solving steps, which we've seen in a couple of different contexts now, we just need to kind of glue all of that together in the right way to be able to solve these equations and get our answers in the simplest form. Any questions on anything so far? Okay. So let's shift gears now and move to 5.5, averages and probability. So this deals with some topics that we probably, what we haven't seen before in this course, we haven't seen recently. And some of these topics you might actually never have seen before. So, depending on kind of what your previous instructors chose to cover, you might have seen this a little bit. Most people have seen an average, but uh, what about a median or a mode? Or what about probability or chance? So we're going to dig into some of this in this section. We also have a course that, if you're interested, you could take later on after getting a couple of prereqs under your belt called Probability and Statistics, Math 165. Super interesting course, very much applied to the real world, trying to kind of use math to answer real world problems. And this touches on a couple of topics that we discuss in a lot more depth in that course. Okay, so first off, the average. For whatever reason, textbook authors make a big deal about calling the average the mean. So we'll call it the mean. But the mean or the average of a set of n numbers is as follows. So we always kind of imagine that at first we're given a set of n numbers. So I might be given, say some information about people's heights, right? So how tall are people in inches? Well, maybe I have 10 people in a classroom and I measure their heights and they're 60 inches and 65 inches and 72 and so on, you know. So maybe I have 10 people in class and I measure each of their heights in inches rounded to the nearest inch and I write them down like this. So this would be n equals 10. I have 10 numbers and these would be my 10 values. I'll typically call this a set of numbers or a data set. So we think of this as being data, as being kind of information that is directly gathered from the real world. I directly measured each of these people, their heights. I have a list of numbers. Now, when I have a data set like this, when I have a list of numbers like this, you could imagine, having a set of 10 numbers. That's a little bit hard to understand or interpret or comprehend. If I gave you a data set that's like the height of all of the people in the electronic medical record at UPMC, I mean, I don't know how many, what million, 2 million people or something. Like if I just give you some book of 2 million numbers, that's going to be really unhelpful for you. How tall do people tend to be, or how spread out do their heights tend to be, or right, what's kind of the average height? It's hard to tell anything about that. What would be, say, a typical person's height, for instance, when there are that many numbers. So that's really the goal of these three computations. It's to take a whole bunch of data, crunch it down to a single number, where that single number represents some aspect of that data set. These are kind of three different perspectives on the question that goes something like, what does the typical number in this data set look like? Or what is a typical value in this data set? All right, so what is the average? How do we compute the average? Well, it's the sum of the data values. So it'd be like 60 plus 65 plus 72, etc., divided by the number of values. So divided by 10. Oh, divided by 10 in this example. It's the second time today. I don't remember if it was this class or the other class where I like accidentally moved something and it ended up looking uh, very strange. And now I have this like underline under here that I can't get rid of. All right, whatever. Deal with it later. So the mean, the average is the sum of the values divided by the number of values. The median, well, the median of a set of n numbers is the middle number. Now it's super important. If we're collecting data like this, if I'm going and measuring people's heights, uh, it's almost a guarantee that they're not going to be in any kind of nice order. They're going to be kind of randomly, clustered about, right? I mean, at first I measured somebody who was a bit short, but then I got somebody who's kind of a medium height, somebody who's tall, somebody who's a little shorter than them, somebody who's tall here at the end. These aren't in any particular order. They're all jumbled up. So super important, the median is the middle number, but in the sense of the size of the values. So the very first thing we want to do, maybe I'll actually even bold this because it's sometimes easy to forget. Very first thing we want to do is we want to take our data set and rewrite it so that the numbers are ordered from smallest to largest. The values are ordered from smallest to largest. And then if the size of the data set is odd, if I had collected 11 people's heights or 13 people's heights, then there's a very clear middle number, right? If I have three numbers, there's a middle one. If I have five, there's a middle one, right? Two to the left, two to the right. If I have an even number of data values, say like four of them, there's no middle one. The middle kind of falls directly between two numbers. So then what I do is I take my two middle ones and I average them. I take their mean. And the mode is the most frequently occurring data value. All right, so let's actually, I think discussing these like this is a bit abstract. Let's go and compute these for a couple examples. So let's take a look at this list of 5 numbers, this data set of size 5. And let's try to compute the mean, the median, and the mode for this data set. So let's start with the mean, or the average. So what do I want to do? The first thing that I want to do is in the numerator, I want to add up the values. So in the numerator, 3 plus 8 plus 2 plus 2 plus 5. And then in the denominator, I see that there are 5 total values. So I divide by 5. 3, 8, 2, 2, 5. There are 5 data points in this data set. So I divide this by 5. Let me simplify the numerator first. 8 plus 2 makes 10. 5 plus 2 plus 3 makes 10. That makes a total of 20 divided by 5. And I think we know that 20 divided by 5 is 4. So the mean for this data set is 4. Yeah, so the median, we have to be careful because remember with the median, we want to order the numbers first. So for the median, this kind of 3, 8, 2, 2, 5, these are all jumbled around in random order. So the first thing I want to do is rewrite my data set, starting with the smallest values and going up to the largest. So what I'll do is I'll kind of look through here. I'll take the smallest value, say one of these 2s, I'll cross it out and I'll write it down here. I'll take the next smallest value. There's still another 2. I'll write it. The next smallest is 3, and then 5, and then 8. So I've written this data set in increasing order. So it goes from smallest numbers to largest numbers, smallest values to largest values. And here I want to pick the middle number. So I can kind of see my middle number here. If I had a larger number of data points, then maybe what I would do is I would kind of get rid of one smallest and one largest, get rid of the next smallest and the next largest. And when I work my way down to where I can't get rid of the 3 because there would be nobody to kind of match it against, the smallest versus the largest, that's my median. So median is 3. And then lastly, my mode, I guess I'll do it in red. I'll do it in red because I don't like the mode. The mode is kind of a poor measure of center in very many cases. So that's the reason that I don't like it too much, but that's something we discuss more in probability and statistics. So the mode, what I do is I'm going to write down each data value that I see pop up. I see that there is a 3, I see an 8, I see a 2, and a 5. And I'm going to count the number of each of these. So value versus count. I see 3 occurring, and I'm up here in my data set just to be clear. I see 3 occurring once. I see 8 occurring once. I see 2 occurring twice. There are 2 instances of the value 2, and 5 occurs once. The mode is the data value with the highest frequency or the highest count. So the highest number of occurrences, the highest count is 2. That indicates a mode of 2. So importantly, the mode is the data value to, it's not the frequency to. That's a little bit hard to kind of see in this example, but I think as we go through a couple more examples, we'll get the hang of it. Okay, let's take a look at this problem. I kind of know that it's often nice to have my data already ordered according to value. So what I'm going to do is whenever I see a data set, I'm just going to automatically rewrite it from smallest to largest. So let me go ahead and do that here. So the lowest number that I see is 29. The next lowest looks like 34. And then I think 41 is next, then 45 and 61. I kind of cross them out as I go along to make sure that I get them all, that I don't miss any, that I don't double count any, that I don't, don't write 41 down twice by accident or something. Okay, so let's compute the mean, the median, and the mode for this data set. We have 5 data points here as well. So for the mean, I'm going to add up these numbers, 29 plus 34 plus 41, 45, and 61 all get added together, divided by 5. So I have a good bit of addition to do here. So let's go ahead and add these. So here we're adding up multiple whole numbers. We just stack them up, the ones places all over the ones places, the tens all over the tens places in orderly columns. And then I go ahead and just add them like normal. I see a 9 plus a 1 gives me a 10. 4, 5, and 1 gives me another 10, so this gives me 20. And then 2 plus 2 is 4, plus 3 is 7. Plus 4 more is 11. Plus 10 is 21. So this gives me 210 divided by 5. I could come over here and do long division, or I could use some of my fraction rules or fraction properties that I now have under my belt. I know that 210 is 21 times 10. And I know that 10 is 5 times 2. I see that I have a factor of 5 in the numerator and the denominator that can divide out. I'm left with this 21 times 2 divided by 1, or just 21 times 2, which is 42. So the mean of this data set is 42. For the median, nicely enough, I already have my data set written in order. And I see that my middle number is going to be just 41. I can either just kind of look at that. This is a small enough data set that I can just figure out that's the middle number looking at it. Or I can, if I had a larger data set, I can kind of chop off one largest and one smallest, next largest, next smallest, and work my way down to where I'm left with either one or two data points. And then what about the mode? Well, kind of unfortunately, these are 5 different numbers. So my different values, let me make a column header. 29, 34, 41, 45, and 61. They each have count or frequency 1. None of these is the clear winner. None of these is the clear value with the higher frequency than the others. in this case, we would say that this data set has no mode. And that's one of the issues with the mode. There are other issues with the mode as well, but one of the issues with the mode is that, in a lot of data sets, the mode just doesn't exist. There's no most frequently occurring data value. I just have 5 different numbers that are my data set. There's no one that's more frequently occurring than another one, nothing like up here where 2 happen to occur twice and the others only once. Yeah, and median number. Okay, let's look at this example. The number of minutes it took Jim to ride his bike to school for each of the past 6 days was 21, 18, 16, 19, 24, and 19. And let's try to find the mean and median number of minutes for his bike ride to school. Why might we want to know a mean or an average? Well, that tells us kind of the typical value of that of the data point and data set. So for instance, if I want to kind of plan for a number of minutes that it's going to take me to go to school each day, I kind of average together my experience over the past, week or a little longer than a week. And maybe that gives me an idea of how long I can expect it to take me tomorrow or the next day. Maybe I can plan for that amount of time, build that into my day. Um, Probably leave a little bit earlier than that because it might take me a little longer than average on some days. Uh, but that at least gives me kind of a starting point to make my plans. Okay, so let's compute the mean and median number of minutes. Why don't we start by just writing these in order? So my lowest number is 16, and then 18, 19. We have another 19, so I'll write that again. 21, and 24. So now I've got these in order. I'll find the mean. Note that we don't have to write them in order to find the mean, but if we're finding the median anyway, you know, it's a little easier to keep track of where we are, or, make sure that we have included all of the data points when they're in order. So it doesn't hurt the mean, it helps a little bit, and it's necessary for the median. So we might as well do it ahead of time and, get the slight benefit for the mean. So I see I'm adding together 6 numbers. There were 6 data values or 6 days that he got some measurement for. So I'll divide by 6. Okay, I need to do this sum. Let me come off to the side here and do it. And one thing that I like to do is try to group together pairs that work nicely together. So for instance, 16 and 24 make 40. Let me actually write that a little further over to the right. 16 and 24 make 40. 19 and 21 also make 40. And then I have to add 18 and 19 in there. So, but this makes it a little more manageable. It makes it a little easier to do because I can add a bunch of zeros. 9 and 8 is 17. 4 plus 4 is 8, plus 3 is 11. So it looks to me like I have 117. This is saying that he spent a total of 117 minutes over these 6 days riding to school. So this is the total number of minutes. This is kind of like in units of minutes, and the 6 is in units of days. So my average is going to be in minutes per day. Is the unit. What's 117 divided by 6? Well, okay, if I do, I I suppose I could do the fraction trick here. I see that 7 plus 1 is 9. 9 is divisible by 3. So I know that 117 is going to be 3 times something. 3 is going to be a factor of 117. I could go that route. But I do see that 6 is divisible by 2, and 117 is not an even number. It's not going to have a factor of 2. So I'm going to have to divide at the end anyway to get a decimal answer. Why don't I just divide now? Let's take 117 divided by 6. Just do that from the beginning. Does 6 go into 1? No. Does 6 go into 11? Yes. How many times? Well, it goes in once. 1 times 6 is 6. 11 minus 6 is 5. And I bring down my 7. Does 6 go into 57? Yes. Well, I know 6 times 10 would be 60. So 6 times 9, just a little bit less, should work. 9 times 6 is 54. 57 minus 54 is 3. So I have 19 with a remainder of 3. I could either write this as 19 and 3/6, then kind of go from here. Or I could go a step further. I could say 117 is 117.0. Bring my 0 down. 6 goes into 30 how many times? 5. 5 times 6 is 30. I've got a remainder of 0. Nothing more to bring down. I've kind of run my pieces together here, but so I could see, I see that I can either write it as, say, a mixed number as 19.5, or as a decimal number as 19.5. So on average, it takes Jim 19.5 minutes to ride his bike to school. Some days it's a little bit longer, like 21 or 24. Some days it's a little shorter, like 16 or 18, but on average, 19.5 minutes or 19.5 minutes per day. Let's compute the median for the data set as well. Let me try to copy this down. All right, so let's compute the median. I've already written the data set in increasing order, so I'm good there. I want to find the middle number. So I can start kind of crossing off one lowest with one highest, the next lowest with the next highest. If I try to keep going, I'll end up crossing off both of these middle numbers and be left with nothing because I have an even number of values here. I have 6 of them. So I get out to the middle, and my median is the mean of the two middle numbers, 19 and 19. But nicely enough, the mean of 19 and 19 is 19 plus 19 over 2. That's just 19. So Jim's median minutes per day to ride to school is 19, and his mean was 19.5, right? These different measures of center, mean, median, kind of mode, they're different ways of trying to answer the same question. They have slightly different nuances and intricacies to each of them. It's actually kind of nice. They actually all derive from the same underlying structure. There's an underlying mathematical structure that gives rise to all these different measures of center that we're discussing here, as well as a bunch of others. But so they are all deeply connected to one another. But at the surface level, they have some different characteristics. And again, that's something we talk a lot more about in stats course. Any questions so far? Okay, let's compute the median for this data set. The mean would be kind of a pain. It would be a lot of calculation, but can we do the median? Well, I know that if I'm looking to compute a median, the first thing that I want to do is order the data from smallest to largest. So let me go through here and order my data from smallest to largest. What's my smallest data point? Well, I see a 27 point something. I don't see any whole number part that is less than 27. So that's got to be my smallest. I cross it out and copy it down. So I don't see any other 27s. Here's a 28 though. There are no other 28s. So this has got to be the next smallest. I don't see anything else in the 20s. So now we're into the 30s. I see a 30.4. Is there anything else that's 30 point something? No, there's not. So 30.4 is next. I see a 31.6. Is there any other 31 point something? No. 31.6 is next then. I see a few different 32s, 32 point somethings. In fact, I see 4 of them. All of the rest are 32 point something. So now I go down to my 10th place to break the tie in the ones place. 32.5 is smaller than 32.7 or 0.9. So there's a 32.5. And I have 2 copies of that. I better write it twice down here. 32.7 next. And 32.9 after that. I have 1, 2, 3, 4, 5, 6, 7, 8 of these. And if I check my original 1, 2, 3, 4, 5, 6, 7, 8, I think I've gotten everything. I was careful to cross off and copy down, and I've kind of checked that the counts match up. So pretty confident I have everything. So I want to compute a median. For the median, I've ordered the data in terms of increasing value. And then I want to kind of whittle my way down to the middle. So I'll cross off the lowest and the highest, the next lowest, the next highest, the next lowest, and the next highest. And if I went a step further, I would have nothing left. So I take my 2 middle numbers. This is an even number of values I have in this data set. I take my 2 middle numbers and I average them. 31.6 plus 32.5 over 2. There are 2 of them that are contributing to the sum, so I divide by 2. I take my mean, or the average of these 2 numbers. Let's figure out what this is. Let me get a little more space here. So I add these 2 numbers together. My decimal point just comes down. 6 plus 5 is 11. Write the 1, carry the 1. 2 plus 1 plus 1 is 4. 3 plus 3 is 6. So this gives me 64.1 divided by 2. And then how do I do this? Well, I have 64.1 divided by 2. 2 goes into 6 3 times. I am being careful now. Sometimes with long division, I'm a little bit sloppy, especially when it's like whole number long division like we had up here. But whenever I have decimal points in play, I'm being really careful to keep my columns lined up. So 2 goes into 6 3 times. 3 times 2 is 6. 0, bring down the 4. 2 goes into 4 twice. I've run into my decimal point. Let me copy that down. 2 times 2 is 4. Bring down the 1. 2 goes into 1, well, 0 times. 0 times 2 is 0. I stick a buffer 0 in at the end here. I know 64.1 is the same as 64.10. Bring that down. 2 goes into 10 5 times. 5 times 2 is 10. I have 0 remainder, nothing left to bring down. So my answer is 32.05. I note that is a number that's in between these two, so I feel confident in that, right? That's kind of a reasonability check. If I average a bunch of numbers together, the average that I end up with, like say the 19 or the the 19.5 up here should be between the smallest and largest value that contributed to that average, right? 19.5 is between 16 and 24. It will be silly to say that all of Jim's rides took from 16 to 24 minutes, but his average, minutes per ride was like 28 or something. So that's a reasonability check we can apply. So we have the median for this data set. We could, in theory, compute the mean, but that would be a bit cumbersome. So our focus here is less on doing a bunch of operations and more on seeing how those operations fit in with these new ideas of mean, median, mode, and probability. Okay, on to the next example. Sal recorded the amount he spent for gas each week for the past 8 weeks. Again, maybe Sal is looking to budget for the upcoming week or the upcoming month and is going to use this as a basis for how much he thinks gas is going to cost for the next week or month. And here were the amounts. So we see a bunch of decimal numbers. We want to find the median amount. So again, I'll start by looking, by almost like sorting these, like we would have in a dictionary, right? If we were sorting words by in alphabetical order. I couldn't think of the word there for a minute. I was stuck on the word dictionary. If we were putting words in alphabetical order, we look at the first letter, the second letter, the third letter, and so on down the line. We'll kind of do the same thing here. So I see that there are some numbers in the 30s. I see 30 point something. I don't see any other 30 point something. So 30.96 is the first number. I won't copy down the dollar signs. I'll just remember these are all in dollars. There are a couple more numbers in the 30s. 32 is less than 38, so 32.18, 38.65. Some numbers in the 40s, 40.23, nothing else has 40 with 0 ones. So that'll be next. I see 41 is going to be less than 44. Oh, I skipped over one. I wasn't being careful. 41 is less than 44. It's also less than 43.68. So 41.37 is next. 43.68 is after that. Then 44.72. And finally 51.50. So I had 1, 2, 3, 4, 5, 6, 7, 8 that I started with, and 1, 2, 3, 4, 5, 6, 7, 8 that I copied down here. And again, I can cross off one smallest with the largest, looking for the median here, the middle number. Next smallest, next largest. Next smallest, next largest. Since I have an even number of data points, I have to average the two middle numbers to get the median. Okay, so what do I get out of here? Well, I might be able to even just do this in line. If I think in terms of dollars, I have 37 cents plus 23 cents. That's like 50 cents plus 10 more cents, or 60 cents. So 0.60 or just 0.6 for the cents. $40 plus $41 is $81 over 2. So this is kind of like having 8 $10 bills and then like maybe 16 dimes. Half of that is like 4 $10 bills. So $40 and 8 dimes. I'll throw my unit back on, right? Sometimes thinking this way can be really helpful, save us a lot of time. There's nothing wrong with coming off to the side and doing our addition and then doing our long division. There's nothing wrong with that. So if you didn't see this or you're not comfortable with kind of taking that quicker couple steps, not a problem at all. Go off to the side, do the decimal addition, get your answer, do the division by 2, get your answer there. But sometimes we might, look at a particular problem and say, hey, this meshes pretty nicely with maybe, for instance, my idea of currency. Well, this is actually currency, but I can imagine pretty easily, you know, adding $40 and $41 together and adding these amount of cents together and get my sum pretty quickly. Or I could, imagine having $81.60 as 8 $10 bills and 16 dimes. And I could split that in two pretty easily. 4 $10 bills each and 8 dimes each. So maybe you recognize that, maybe you're comfortable with that, maybe you're not, and it's perfectly fine to do the decimal addition and the long division. Okay, and then one last example in this subsection. Let's compute the mode of this big long list of numbers. So how I'm going to do this is I'm not going to order this because I only want the mode. It's not going to really benefit me to order it. But I'm going to start with just 42 with my first number here, my first value. And then I'm going to go ahead and count the number of times it occurs. There's 1, as I'm working my way along here. There's 2 and 3. My count or my frequency for 42 is 3. My next number that occurs in the sequence is 28. So there's 1. Does it occur anywhere else? There's 2, 3. My next one is 32. There's 1, 2, 3, 4, 5, 6. 32 occurs 6 times. 35 is next. There's 1, 2, 3, 24. There was 1, 2, and only 2 of them. 48. It looks to me like there's only 1 of those. And I think all that's left is these 2 30s. 30, there are 2 of those. Now I want to find a way to check this. That was a lot of ciphering and counting. So let me figure out what's the total number of data values. So I'll block them off in groups of 5. 1, 2, 3, 4, 5. There's 10, 15, 20. It looks like 21 total. And let's add up our total of this counts column and make sure it adds to 21. 3 times 3 is 9, plus 6 is 15, 16, 17, 18. Did I miscount something? So I'm getting 20 versus 21. Did I make a mistake?
Sorry, sir, why you didn't pick the 45?
Ah, yes, thank you. There's a 45 here that was hiding from me. So 45 and 1, shimmy that 1 in there, and now we have 21. So I'm looking for the highest count. The highest count is 6, and that's associated with a value of 32. So my mode would be 32. So my mode is the data value that occurs most frequently. In this case, 32 occurs 6 times. 32 occurs more times than any other number, like 28 that occurs 3 times or 48 that occurs once. So my mode is 32. So the mode is simple in principle to calculate, but for a longer list of numbers, it can be a bit tedious. Any questions on anything with mean, median, or mode? Okay, so jumping down then to the kind of other subsection of this section, probability. So again, in something like a statistics course, we would talk a lot about probability, what it means, and so on. Lots of different ways to approach computing probability. We're just scratching the surface here. So the first question is kind of what is probability? Well, probability is kind of like the chance of something occurring. If you open your weather app and you see there's a 30% chance of rain tomorrow, what we kind of mean by that is if you looked at like, let's say 10 similar days, or sorry, if you had a 3 in 10 chance of rain tomorrow, we haven't quite gotten to percents yet. I think a lot of us are, fairly comfortable with percents, but we haven't technically gotten to percents yet. But if you see a 30% chance of rain, or say the chance of rain, the probability of rain was 3/10, what's kind of meant by that is if you looked at 10 similar days, 10 days where you checked your weather app and it said tomorrow was a 3/10 probability of rain, you would expect that on 3 of those days it would rain, and on the other 7 it would not rain. So that's what we call the probability of an event. Probabilities are almost always expressed in percents, which is why it's a little kind of strange for the book to include it in this section when we haven't gotten to percents yet. So you almost always, somebody says like, oh, there's a 50% chance of, flipping a heads on a fair coin or something like that. They're usually expressed in percents, but I'm going to try really, really hard not to say anything as a percent because we haven't technically gotten there yet. I'll try to keep it as fractions or decimals, which we have gotten to at this point. So the probability is like the number of times the event occurs over the total number of outcomes, or the number of data values that satisfy the event that we're interested in, say maybe whether it rains, divided by the total number of data values, like the number of days that we're looking at. So if I had 10 days, just kind of represented by these 10 circles, and if it rained on 3 of them and it did not rain on the other 7, we would say the probability of rain is 3 because there are 3 days that it rained. The rain event occurred 3 times, divided by the total number of outcomes we were evaluating these 10 days, 3 over 10. 3 over 10, or we could write this as 0.3 if we wanted to write it as a decimal. So let's look at this example. Jessica is one of 8 kindergarten teachers at Mandela Elementary School. One of the kindergarten teachers will be selected at random to attend a summer workshop. Find the probability that Jessica will be selected. So we can draw this out kind of pictographically. There are 8 different teachers. Jessica is one of them. And the other ones I'll just call N for not Jessica. They're all equally likely to be selected. So the probability of Jessica being chosen is the number of events that result in Jessica being chosen. There's only one of those, divided by the total number of possible outcomes. The total number of possible people that could be chosen is 8. So 1/8. The probability Jessica will be selected is 1/8, or we could write this as a decimal. 8 goes into 10. 1 times 8 is 8, leaving me with 2. I need another decimal place. I'll tack on another decimal up here, bring it down. 8 goes into 20 twice. 2 times 8 is 16. 4, tack on another decimal place, another 0. 8 goes into 45 times. 5 times 8 is 40. 0 remainder, nothing left to bring down. So the probability of Jessica being selected, we could write as a decimal as 0.125. So another example, Monica has 2 strawberry yogurts and 6 banana yogurts in her refrigerator. She'll choose 1 yogurt at random to take to work. What's the probability she'll choose a strawberry? So here she has 2 strawberry and 6 banana, so 8 total yogurts. Two are strawberry, and that's what we're interested in finding the probability she'll choose a strawberry. And the rest are banana, which are not strawberry. I'll write those in red. So what's the probability of her picking a strawberry yogurt? There are 2 of these outcomes that result in a strawberry yogurt being chosen, divided by a total of 8 possible outcomes. 2 divided by 8, or 1 divided by 4 when we divide out the 2 from the 8. Or we know that 1/4 is 0.25. So the probability of choosing a strawberry yogurt is 1/4, 0.25. Any questions so far? All right, next example. Donovan is considering transferring to a 4-year college. He's considering 10 out-of-state colleges and 4 colleges in-state. He will choose 1 college at random to visit during spring break. Find the probability that Donovan will choose an out-of-state college. Some of the examples in the book or that were possible to choose for WebAssign are really silly. It was like, somebody got accepted to 5 colleges and they're going to choose a college at random. It's like, who's going to just randomly choose what college they go to? Or I don't know. Like, they were quite big life decisions that these people were choosing at random. It's a little bit like there's a famous physics textbook problem that gets shared every once in a while where it's like there's a girl standing here. It's like a picture of a girl, and she has a book, and the book weighs like 1 kilogram, and she drops it, and it, goes to the ground, and how much potential energy is lost. And the girl is holding the book at like a height of like 5 meters. It's like, wait, 5 meters? That's like 50. This girl is like as tall as a house. Like, I don't know. I think sometimes the textbook writers or publishers or whoever, uh, they just toss a number or an idea in there and don't really think about whether that's a likely thing to happen. So please don't choose your college randomly. Um, so, okay. So Donovan is considering 10 out of state and 4 in-state colleges, so 14. Maybe I'll write 2 rows of 7. And we want to know the probability that Donovan will choose an out-of-state college. So the out-of-state is what we're looking for. I'll write these as O's. So there's 5, 6, 7, 8, 9. There's the 10 out-of-states. Those are the outcomes that satisfy the event that we're interested in. And for in-states, these are the outcomes that do not satisfy the event that we're interested in. So the probability of, let me keep my color scheme consistent. The probability of choosing an out of state, well, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 out of state outcomes, 10 outcomes that satisfy that event, divided by the total of 14 total outcomes. 10 of the colleges are out of state, divided by the total of 10 plus 4, or 14 total colleges. Or this is 5/7. we'll leave that as 5/7 instead of turning it into a decimal. The sevenths actually work kind of cool. This is a little aside. We have a few extra minutes. 1/7 is 0.142857 repeating. This whole string of 6 repeats. It's 0.142857, 142857, 142857 forever. 2/7 is 0.285714 repeating. So we see the things just kind of shifted over a couple of places. 3/7 is 0.571428 repeating. So we can say, okay, like 3/7 should be about 3 times 0.14. Oh, I skipped one. I jumped the gun. 0.428571 repeating. I jumped to the next one accidentally. So I can see that 3/7 is 3 times 1/7. It should be about 3 times 0.14 or about 0.42. And this sequence just kind of continues, 0.428571, right? I know it should be about 0.42, and I know that it's got to follow the same order. 4/7, well, 4 times 14, that's 40 plus 4 times 4 is 16. That's about 56 or 57-ish, 0.571428. And these are repeating. So it just cycles through like this. 5/7, 5 times 0.14 is 50 plus 20 more, or that's about 0.714285. And 6/7, we start with 8, 0.857142 repeating. So the sevenths are actually kind of cool. Like they have this like 142857, 14 doubled is 28, 28 doubled is 56. You bump that up one to get a 57. So there's a nice little pattern here in the sevenths. So we could figure out that 5/7 is 0.714285 repeating, but we would have to do a heck of a long division problem to verify that that repeats. We'd have to do what, 12 steps or something of long division. And I don't mind doing long division, but I really don't want to do 12 steps of one long division problem. But this is kind of a cool little pattern for the sevenths. Okay, one last example. Joaquin gets paid every Friday. His paychecks for the past 5 Fridays were 315, 236.25, 236.25, 236.25, and 393.75. Find the mean, median, and mode. So maybe, Joaquin might work on commission or something. He might get flat rate plus commission. So maybe this is a flat rate, made no sales these 3 weeks, but made an okay sale this week and a really good sale that week, for instance. So when your income fluctuates like this, how do you plan, right? How do you budget for a month or for a couple weeks or something? Well, you can work with your average income. So you can say, okay, I mean, some weeks it's going to be a little higher, some weeks a little lower, but can I get an idea of what my average income per week is and then make my monthly budget based on that average income? I'll probably have some weeks where I'm a little below that and things might be a little bit tight for that week, but I also have some weeks where I'm a little above that. And I can use those to kind of compensate for the lower weeks. So he's got five paychecks here. I'm not going to write these in order because there's only 5 of them. It's easy enough to find the median, and that's just a whole bunch of numbers to write out. We only got 9 minutes left. So the mean, we have to add all these together. 315 plus 236.25 plus another one of those plus a third of that 236.25 and then plus 393.75, all divided by 5 because there are 5 numbers we add together. So we're finding his mean or average income per week. Let's come over here and do that. Well, let's come down here and do that because I've already taken up that area with the sevenths demonstration. 315, I know that 315 is like 315.00, 236.25, and I have 3 of those. It always like amazes me that my hand writes what my mouth is saying rather than what my brain is thinking. 393.75. So did I copy all those right? I think so. Yeah, it looks good. And I want to add these together. So 5 added to itself 4 times gives me 20. 4 lots of 2 gives me 8 plus 7 is 15. Let me bring the decimal point down. 3 lots of 6 is 18, plus 3 is 21, plus 5 is 26, plus 1 is 27. 3 threes give me 9, plus another 9 is 18, 19, 20, 21. And I have 4 twos is 8, plus 2 threes, 8 plus 6 is 14. So for the total of these 5 Fridays, Joaquin made $1,417.50. We need to divide this by 5. Now there's a little trick here I actually didn't show you before. But one thing I can do when I have a factor like 5 in the denominator, dividing by 5 is kind of a pain, but dividing by 10 is super easy. Can I find an equivalent fraction with a denominator of 10? Well, yeah, I just multiply denominator by 2 and do the same for the numerator. So now I get to divide by 10, which is very nice. The downside is I need to double this. I need to do a multiplication problem. But oftentimes multiplication is a lot easier to do than division. So if I have $1,417.50 times 2, well, the 1400s double to 2800, and then $17.50 doubles to, well, $17 doubled is 34, and then the 50 cents doubled gives me one more dollar, 35. Now, again, if you don't feel comfortable with taking a shortcut like this, it's perfectly fine to just do your 1417.5 long division with the 5 on the outside, go through the process, but we can make things a little bit simpler doing this. And I know that if I divide a decimal by 10, that moves the decimal point 1 to the left, 283.5. So Joaquin's average pay per week was $283.50. So if he's going to budget for, say, the next 4 weeks, he might take 283.50, multiply it by 4, and say, that's the amount of money that I've got to work with for the next 4 weeks, and allocate it to, whatever he needs. And there might be some weeks that he's a little bit short, maybe doesn't make a sale that week and needs to push a bill that week to say next week to pay it. And then some weeks where he makes a good sale, gets a nice commission, and can, pay a couple bills ahead of time or something. So what's the median? Well, the middle number when ordered in order, 236.25, we have 3 of those, and those are also all the smallest numbers. Then 315 is next, and 393 is the highest. So the middle number after we order will still be 236.25. So Joaquin's performance varies. Sometimes he gets kind of a lower paycheck, sometimes a higher paycheck. And in fact, this 393.75 was kind of a pretty high paycheck. When we have kind of an outlier like that, one number that kind of doesn't seem to really fit in so well with the rest of the numbers, sometimes the median is a better measure of center. So if I was advising Joaquin, I might say, well, maybe make your budget off of 236.25 instead of 283.50, because this seems like it was maybe an outlier. It seems like something that might not happen too often because it's so far above like 315 or 236. And you don't want to count on that, right? You might have made one big sale. Now you might make one big sale every 5 weeks, but you also might make one big sale every 20 weeks. And you really don't want to count on making one big sale to kind of carry your whole month. Now, if 6 months or a year from now you have a lot more data and you do see that you pretty regularly make one big sale every 5 weeks, then maybe reevaluate it, right? At that point, you might say, okay, it's a little bit less of an outlier because I know that it's a little more consistent. So that's digging a little bit deeper into like, why would I use, say, a median over a mean in a case like this, where I see kind of one big outlier that's affecting the mean a lot. The median might be a little bit more of a safe bet, a little more of a conservative estimate. We'd rather have money at the end of the month than month at the end of the money, as is sometimes said. And then the mode, what's the most frequently occurring data value? Well, the 236.25. So in this case, the mode turns out to be the same as the median. Any questions on anything from today?